So as a result of conceptual data modeling, last time what we did is that we made something like this, which we call as an entity relationship diagram, which is ERD. So last time we made that. And once we have ERD, we are able to implement a database system. So by just looking at ERD, everyone in the company and everyone in the organization, they should have the same understanding of how your database system look like. So once you have ERD, the next step is basically the relational data modeling. So what we do here is this. So last time we made ERD, but ERD is more of the conceptual model. So what we are going to do in this second step is basically mapping ERD into relational model. So it's more similar to database implementation. So basically, by doing relational modeling, we are going to convert ERD into relational model like this. So here at this stage, we are actually going to define table, so how the table should look like and which column should be there. And we are going to also define the primary key and foreign key to make the relationship. So this is the second step which we are going to do today in the first part of today's class. And in the second part of today's class, we are going to talk about physical implementation. So once you have this relational model, then it is very straightforward to implement database in the database system like MySQL or other SQL database software. Basically, you are simply, so you have everything like the table and the relationship, all the structure, you simply implement that in the database software. So that's what we are going to do in the second part of today's class. So now, in the first part of today's class, we are going to focus on this one, relational data modeling. So this is what we did last time, the entity relationship diagram. So simply, briefly to recap, basically, from the organization, it performs multiple business, and we identify the business event. And for each business event, we have some kind of, so each business event like this, we have some kind of rules, which is business rules. And based on that, we infer entity, relationship, attributes, and the cardinality like this. And then we'll have a ER diagram like this based on each business event. So that's what we mainly talked about last time. So what we are going to today is again relational modeling. Basically, it's about mapping conceptual model, which is ERD, into relational model. So this is what we are going to focus today. And that's what we are going to talk about today. So the first step, also I think there's a slight delay here. Yeah, but anyway. Okay, so first step we are going to do is basically from the ER diagram, which is a conceptual model, we identify the entity. And we are going to translate all the entity into table. So basically here in the first step, when we are translating it from entity into table, we are going to define table structure, and we are going to also define what will be primary key and what will be fields. And the second step is a relationship. So in the first class, so I mentioned briefly about this. Basically, to make a relationship between tables, we are going to use the concept of primary key and foreign key in the database. So in the relational model, basically, we are going to define foreign key to make the relationship. So here, relationship will be translated into foreign key. So we are going to define what would be foreign key and where it should be stored in the table. So that's the what we are going to do when we represent the relationship using foreign key. And there are several rules how you can map relationship into foreign key. So I'm going to talk more about details about this later. But once you follow this systematic rule, you can change all the ER diagram into relational model very easily and very straightforwardly. So that's what we are going to do today. And the relational model can be directly, basically mapped into physical implementation once you have it. So this part is very important because it's the kind of last step you are going to go through before physical implementation of the database. So if you have any problem in the relational model, when you implement your database system, the problem will be still there. So this part is very important. So let's actually do it. So the easiest way to understand how to translate this kind of ER diagram into relational model is just by doing it by yourself. So let me give you some examples of how we can actually translate ERD into relational model. So this is the ER diagram based on the business event, a professor teaching a course in the university. So to briefly remind you, we have these two entities here, professor entity and the course entity. And professor teaches many courses. So here is a 0 to many. And from the course perspective, every course can be taught by only one professor. Then we will have this one-to-many relationship between professor and course entity like this. And there are several attributes like this. The first step of translating ERD into relational model is changing all the entity into table. So all the entities in your ER diagram will become a table in the relational model. So we have a professor and course entity. So based on the professor entity, we make a professor table. And in the relational model, we are going to define table in this format. So we make a box shape like this. And we put the name of entity on the top. And on the right side here, we put all the attributes. So all the attributes here goes there. And for the primary key, which is step ID, we specify here that it is primary key. So we know that step ID is a primary key of this table. So we define the table structure like this for every entity. So that's for the professor table, and we can do the same thing for the course entity. So course entity becomes a course table like this with all the attributes, and we specify what is a primary key like this. So that's the first step. So first step is pretty straightforward and easy. And the next step is representing relationship into relational model. So it depends on the relationship type actually. So you have to look at relationship type, and depending on, you have to follow this rule. So the first one is a one-to-many relationship. So most common relationship you have in the database system is a one-to-many relationship. So when you have a one-to-many relationship between two entities, basically you can follow this rule. How you can represent relationship? Basically, you can use primary key of one side table as foreign key of many side table. So here, this is one-to-many relationship again. And on the professor side, the maximum cardinality is 1. So we call this as one side table. And course entity side, the maximum cardinality is many. So we will call this course table as many side table. So basically, what we do is very simple. Primary key of one side table, which is step ID. We are going to use that as a foreign key of many side table. So on many side table, currently there is no step ID. So in this table, we are going to add step ID here as a foreign key. So we specify that in the table like this. So then basically, now we have a primary key here, foreign key here with the same attribute. Then we can make the relationship. So in the relational model, after putting foreign key, you simply link those two together like this and put the same cardinality option here. So basically this relational model with the professor entity, course entity with the primary key and foreign key, now it can represent how the relationship can be made in the database system based on with these two tables based on the foreign key like this. So it's quite easy, right? So basically, it's the case of a one-to-many relationship, and whenever you have a one-to-many relationship in your database system in the ER diagram, you can just follow this rule to create the relational model like this. Then the nice thing about relational model is this. So the reason why we are doing relational model is because we want to do physical implementation systematically. So once we have a relational model like this, which we just made now, then it is very easy to know how our records will be stored in our database system. So when you have this, basically, the table becomes real table in the database system. So the professor table will look like this with all the attributes here, which we specified here, with all the data in each row like this. For the course table, it's the same. When you implement this in the database system, it will be course table like this, and you can add the data. And as you see in the database system, the primary key of step ID and foreign key of step ID is connected. So later, when we talk about SQL, we can use this information. So we can use this step ID to search who this person is in related table. So we are going to use that information to find the related information in another table. So basically, once we have a relational model, we have the understanding of how database structure will look like and how information will be stored there. So earlier example was the case of a one-to-many relationship, and earlier I mentioned that based on the relationship type, the rules might be slightly different. So let's think about one-to-one relationship. So in this case, we have two entities, person entities here and passport entities here. Basically, this is the business event about giving a passport, making a passport to a person. So in the government database system, they have each person's record based on the Hong Kong ID, which is the primary key in this case. And every person may or may not have a passport. So if they don't apply for a passport, they may not have it. So here is 0 to 1. And if the passport is issued, there should be one person who has this passport. So here is also 1 and 1. So we have a one-to-one relationship between person and passport in this case, basically. So how we can translate this one-to-one relationship into relational model, then you can follow this rule. So basically, you can use primary key of any table as foreign key of the other table. So one way is this. Use Hong Kong ID here, which is a primary key of a person entity, and use that as a foreign key of the other related entity. And put the same cardinality sign here. So that's the first option. So you can do that. So here, if you look at the rule, basically you can use any table's primary key over the other table's foreign key. So this design is okay. Also, you can do the other way too. In the person table, you can use a primary key of a passport table as a foreign key like this. That design is also okay. So basically, when you have a one-to-one relationship in the ER diagram, when you translate that into relational model, the rule is very similar to the one-to-many case, but you can add a foreign key in either table. So it doesn't matter actually. So again, when you have this, basically on the first example here, when we add the primary key of Hong Kong ID here as a foreign key, we will have a person table like this, and the passport table will be implemented like this. And basically for every passport, we can look for Hong Kong ID here, and we can find the person. The same thing applies here. When we add a foreign key passport number into person table, we can simply look for passport number for every person to find the related information in passport table like this. So in this case, either design works fine. So that's a one-to-one relationship. So when I go through it, if you have any questions, just raise your hand and let me know. Okay, so the next one. So this is a little bit complex. Now let's talk about the many-to-many relationship. So when we have a many-to-many relationship, is it possible whether we can use the foreign key approach like what we did earlier? So that's the main question here. So let's think about this business case of a professor applying for the parking permit. So in this business case, the rule is that professor may apply many parking permits, and each parking permit may be shared by many professors. So this was one of the examples we talked about last time. So let's say that we have this ER diagram and we want to translate this into a relational model. Then if we try to utilize the foreign key approach as we did earlier, then actually it will not work. So let me show you why it doesn't work. So if we use primary key of a professor table, step ID, and if we add it here into permit table as a foreign key, then our relational diagram will look like this. But the problem is this. When you try to implement this in the database system, the professor table will look like this. So it's fine. For each professor, we have step ID and we have information. And for the permit table, there's a problem because permit number is the primary key. So we have each permit information in each row. And for the step ID field, permit 101 can be shared by multiple professors in this case because it's a many-to-many relationship. Then we may try to put multiple numbers, multiple steps of information here. So this is actually not allowed in the database system. You are able to store only one data in one cell. So in this case, you are trying to store more than one data in one cell in a table. So this design doesn't work in the relational database system. Then how about if we do the other way? If we include the permit number, which is primary key of a permit table, into professor table as a foreign key. Will this work? We have the same problem. So if we try to implement this in the database system, basically it will look like this. So the professor table will be implemented like this. So this one looks fine because each row has each professor's information. However, the new column, permit number, because our business rule is that each professor may have a multiple permit, we are going to try to store multiple data. So this design also doesn't work in the database system. Again, because we are trying to put more than one information in one cell, which is not allowed in the relational database system. So these two approaches doesn't work. So what we have to do is this. We have to get some help. We have to utilize some additional information. So basically, in the relational model, when you translate many-to-many relationship from the ERD, the many-to-many relationship will become a junction or assignment table. So I briefly talked about last time, when you have a many-to-many relationship, it will become a table which keeps assignment information. So basically, that's what I mean here. So relational database does not support many-to-many relationship directly. So it's because only one data can be stored in one cell in the table. So that's why. So what you can do is that when you have a many-to-many relationship like this between entity 1 and entity 2, the relationship will become a junction table like this. So you make a junction table between two relationships. And this table will contain the assignment information. So like who has which permit, something like that. And in the junction table, the primary key will be primary keys of both entity. So basically ID 1 was the primary key of entity 1 and ID 2 was the primary key of entity 2. So we put them together in the junction table and use them both as a composite primary key. So that's how you can design the junction table in this case. And then you are going to connect the same primary key between entity and junction table. So entity 1 has ID 1, which is primary key. It's here, so we connect. Entity 2 has ID 2, which is here. We connect like this. And for the cardinality, so from each entity's perspective, they can sync this junction table as the other entity. What it means is this. From the entity 1's perspective, entity 2 was connected by 1 and many, so we put it there, 1 and many. And entity 2's perspective, entity 1 was connected by 0 and many, so we put that here, 0 and many. So from entity 2's perspective, they think junction table is entity 1, and entity 1's perspective, they think junction table is entity 2, like this. So basically, we bring this here and we bring this here. And for the rest of the cardinality, you simply put 1 and 1. And because it's this, the junction table will keep the assignment information. So if there is assignment, there must be related information stored in these two entities. So conceptually, that's what it means basically. So basically, in the relational database system, what they do is simply this. Because they cannot support many-to-many relationship directly, they are utilizing two one-to-many relationship to mimic the many-to-many relationship in the system. So basically, let me show you another example here based on earlier example we used about the professor applies for the parking permit. So basically, whenever you have a many-to-many relationship, you can just follow the rule I mentioned earlier. The first of all, you put the professor table and permit table based on the professor and permit entity information. And in the middle, you put the assignment table with the primary keys of both entity, which is step ID and permit number, and use them as composite primary key. And then you make a relationship to professor and permit entity based on the same primary key used in both tables. And for the cardinality, you from the professor's perspective, the permit's cardinality, simply bring it here. And from the permit's perspective, the professor's cardinality, simply bring it here. And then for the rest of cardinality, you simply put 1 and 1 like this. Then you can translate any many-to-many relationship in the ER diagram into a relational model like this. So that's what you can do when you have a many-to-many relationship in the ER diagram. So once you have this ER diagram, basically in the database system, when you implement it, your data will be stored in this way. So the professor table will be here with the 3 attributes. Permit table will be here with the 3 attributes again. And the assignment table will become like this. So it has a step ID and permit number, both as primary key. So combining these two information, it will determine that each row has a unique information. So it can have assignment information. So step ID 1111 has a permit number 101 and 103. And step ID 3333 has permit number 101 like this. So in the database system, basically, if I want to look for like which parking permit is owned by this person, then we can look at the step ID of that person, 1111, and we can search it in the assignment table. And there are 2 match here with the different permit information. And we can say that this person has these 2 parking permit like this. And the same way, if we want to know whether a certain parking permit is shared by multiple person, we can start from the permit table. So let's just say 101 parking permit. We want to know who has this parking permit, then we can look at this information here in the assignment table. Then we can find the match here and match here, and we know that these 2 people are sharing the same parking permit like this. So that's how we can utilize a many-to-many relationship in the relational model like this. So last time I mentioned that when you have a many-to-many relationship, you are able to put attributes in the relationship only for many-to-many. That's why. Because many-to-many relationship will become assignment table in the relational model, now you have a table. So basically, based on each assignment, you are able to add additional attributes like this. So if we put time attribute like this, basically our relational model will look like this. So we can simply add the time attribute in this assignment table. And then this will look like this when we implement the database system. So basically in the assignment table, for each assignment, the time information will be stored. So basically, how to interpret this is this. Because these 2 are primary key. So this time information depends on step ID and permit number, which means that for step ID 1111, and for his parking permit 101, he can use only in the morning. And step ID 1111 has another parking permit 103, and he can use that for all day, or something like that. And same for if we only look at 101. So for parking permit 101, it is shared by 2 people, 1111 and 3333. And this first person can use it only in the morning, but for the same parking permit, this second person can use only during the afternoon, like this. So that's basically how you can add additional attribute into the assignment table, which is a many-to-many relationship, and that's how you can interpret the data. So that's what I mentioned last time. Basically, when you have some information which depends on something, you can add it into many-to-many relationship. So hopefully it gives you a good understanding of the many-to-many relationship and how it can translate into the relational model and how it can be implemented in the relational database system. So that's it. So here I prepared, again like last time, I prepared a few exercises so you can try. So basically that's all about the relational modeling. I mean, I have some more information later, but for now that's all. And if you just look at, and if you just follow those steps, you should be able to translate all the ER diagram into relational model and implement it. So let's look at this exercise 1 first. So we want to map this conceptual ER diagram into relational model. So it's a similar example as I showed you earlier. So we have a user entity and the hotel entity. And basically it's about the rating system. So user gives a rating to a hotel. So user can rate many hotels, and each hotel can be rated by many users. And we want, whenever a user rates a hotel, we want to store rating information. So we have this simple ER diagram, many-to-many relationship. So first step is basically translating all the entity into table. So we can start from that first. So we can make the user table. And then we can put the attribute here. So like a user ID, name, email, and phone number. And the second entity is a hotel, so we can make the hotel table here, which contains all the attributes like business ID and the location. So user ID is primary key, so we can specify that it's primary key. Business ID is also primary key, so we can specify that here. And now when we look at the relationship, these two entities are connected by rates relationship, which are many-to-many. So many-to-many relationship should become a junction table. So we make rates assignment table in the middle. And for the primary key of this table, we use a primary key of both related entity. So user table, primary key is user ID, so we bring it here. And hotel table, the primary key is hotel business ID, so we bring it here. And this now for the relationship, we simply connect the same primary key between entity like this. And for the cardinality from the user perspective, hotel was connected by 0 and many, so we put it here, 0 and many. And from the hotel side, user was connected by 0 and many, so we put that here again. And for the rest of cardinality, we simply put 1 and 1. And the last thing is a rating attribute, which is added into rates relationship, which is many-to-many. So here we simply put rating attribute. So that's it. So that's basically the answer for this exercise 1. Okay. So I prepared a few more exercises, 2 more exercises here. So you can try. The second exercise is this. So this is in the case of a unary relationship. So when you have a unary relationship, what you can do? Basically, you can follow the same rule that I showed you earlier. So binary relationship and the unary relationship is not that different. So let me show you the answer. So basically, unary relationship, you can follow the same rule as a binary relationship. The first of all, there's entity, course. So we can make a table. So we can make a course table here, which contains course ID, title, and the units. So course ID is a primary key, so we can specify that there. And now we have this unary relationship. So if you look at the cardinality, basically it's a many-to-many unary relationship. So we can follow the same rule as a many-to-many relationship. So when you think about unary relationship, basically it's like this. So it looks like this, but actually it's the relationship of one course with another course, right? In this case, it can be required course because the relationship is prerequisite. So basically one course is requiring another course as a prerequisite. But these two entities are the same one basically. So that's why we made it as Unary. So we have only one entity. And this is a many-to-many relationship here. So we make that as an assignment table first. So we can have a prerequisite assignment table here. And the rule was that for the primary key of this assignment table, we have to use related entities primary key. So related entity, if you follow this line, is a course ID. So we can put the course ID. So course is requiring another course as a prerequisite. And if we follow this line, it's also course ID. So here we can put required course ID like this. And we can use both of them as a primary key. So basically, course ID and required course ID are saved here as a composite primary key. So how to link this now? So even though it's a unary relationship, it has two lines here, right? So one line here, another line here. So we can do the same thing. So one line can be linked like this, and another line can be linked like this. So you can put it this, or you can link it like this and this. That's also fine. So in this case, I'll just link like this, and yeah. And for the cardinality, so from the course perspective, another course is linked by 0 and many. So we can put that here, 0, many. And from another course, from the required course, it's the same. So 0 and many here. So we put 0 and many here. And for the rest of relationship cardinality, we simply put 1 and 1. So we put 1 and 1 here, like this. So yeah, I think that's all. Yeah, we have everything there. So basically that's how you can translate a unary relationship into relational model. You can basically follow the same rule which we talked about in the earlier for the binary relationship case. Then another question is this. So what if we have a binary unary relationship? So something like, let's say that we have an entity here and we have a relationship here, and it is connected by something like this. One-to-many unary relationship. What if we have this? How we can translate this? So if we translate this, basically it will become like this. So we have a entity, and let's say that the primary key was ID. Then we have a primary key ID. And when we have a binary relationship, when we have a one-to-many binary relationship, the rule was that we use primary key of a one-sided table as a foreign key in the many-sided table. So in this case, primary key of a one-sided table, which is ID, we can use that as a foreign key of a many-sided table. So we can add a foreign key like ID 2 or something like that. And then these are connected together. And for the cardinality, 0 many and 1 and 1 like this. So that's basically you can follow the same rule for unary relationship. So that was another example of translating one-to-many unary relationship into relational model. Okay, so any questions here? Okay, so that's it. So what if we have a ternary relationship? So this one might be a little bit more complex. So let me show you the answer for this first, and let me give you more explanation why we have to follow that kind of rule. The first of all, it's the same for all the entity. We have to make the table. So we can create the professor table, and we can create the course table, and we can create the semester table here. So for semester table, we have a primary key, semester ID, and we have year and term number. For the course table, we have a course primary key of a course ID, and we have a course name, title, time, location. And for the professor table, we have a primary key of a staff ID, and we have other attributes. And here we have this ternary relationship, and currently it's connected by one, many, many. So it's a one to many ternary relationship. And the rule is this: so whenever there are more than one, many maximum cardinality in the relationship, you can consider that as a many to many. So in this case, there are two maximum many cardinality. So you can consider this relationship as a many to many relationship. So if this is a many to many relationship, we have to make a table for that. So we can create a teach table, and we can use and now we have to determine what will become primary key of this table. The first rule is this: so all the many cardinality, all the entity connected by many cardinality here, semester and course, their primary key will be used as a primary key in this table. So semester ID and the course ID will be used as a primary key together as a composite primary key. However, this relationship is also connected with the professor. So staff ID will be added here, and because we have to represent this connection, we are going to use that as a foreign key, but not the primary key, because it's not connected by many cardinality. And then we link them together. So staff ID here is linked, and the course ID here is linked, and the semester ID is linked like this. And for the cardinality, when you have a many to many ternary relationship like this, basically all the cardinality, all the relationship type between assignment table and the related entity will be one to many relationship. So you can think in this way: from the professor's perspective, you have to think how other entities are related. So the other entities are semester and course. The minimum cardinality is 0, maximum cardinality is many. So we put that here, 0, many. From the semester's perspective, it's the same. Though there is 1 and 0, so minimum is 0. There is 1 and many, so maximum is many. So we put 0. Yeah, I think my Apple Pen is dead, so I just explain. Yeah, so it's difficult to explain without Apple Pen, but anyway, so we are going to put 0 and many next to the primary key, semester ID on the teach relationship. And also, if you think from the course perspective, it's the same. The course is related by two entities, but the minimum cardinality is 0, maximum cardinality is many there. So we can put also 0, many next to the CID in the teach table. Actually, yeah, there is a solution in the next page, so let's look at that. It will be easier. So basically, this is the solution here. When you have a many-to-many ternary relationship, basically in that case, it will look like this. So the rule I summarized here, so you can just follow this rule when you have a many-to-many ternary relationship. So the first rule is that when there's when the number of many maximum cardinality in the relationship is more than 1, we consider that as a many-to-many relationship. And once we have that, we use a primary key of many-sided table as a primary key into assignment table. So semester ID, course ID, they are both used as primary key of the teaching relationship. And primary keys of a one-side table will be used as a foreign key into assignment table. So staff ID, which is connected as a 1 maximum cardinality, it will be used as a foreign key there as a staff ID in the teaching table. And all the relationship between entity and assignment table always become one-to-many, and it depends on how they are related. So from the professor's perspective, the minimum cardinality connected with other entity is 0, and the maximum cardinality connected with the other entity was many, so we put 0, many. And for the other entity, it's all same, so we put 0 and many next to it. And for the rest of cardinality, we put 1 and 1, just like what we did before. So basically, that's the rules of translating ternary many-to-many relationship from ER diagram into relational model. So you can just follow this rule, then it should be straightforward. So what if we have a ternary one-to-many relationship? So ternary one-to-many relationship is basically this. When the number of many maximum cardinality in the relationship is 1, we call that as a ternary one-to-many relationship. So as you see here, in this case, there is 3 entity, salesperson, country, and customer. There is a managed relationship. Basically, it's the business event of a salesperson, manage customer in different country. In this case, we have a one-to-one-to-many relationship, and that ternary relationship, the maximum many cardinality is only 1 next to the customer entity. So we consider that as a ternary one-to-many relationship. So when you have a ternary one-to-many relationship, basically, you can put the primary keys of one-sided table as foreign key into many-sided table. So country and salesperson are connected by maximum 1 cardinality. So primary key of these 2 tables, which is country ID and salesperson ID, we put them as a foreign key into customer table like this. And we make a connection, and we use the same cardinality how they are connected before. So that's how you can represent ternary one-to-many relationship into relational model. So here you may think it's something weird, right? So actually it looks like in the relational model, it looks like it's just the 2 one-to-many relationship, not the ternary relationship. Actually that's correct. In terms of implementation, this ER diagram on the bottom is actually same as the ER diagram on the top. So when you have a one-to-many ternary relationship, basically it's the same as having multiple one-to-many relationship. So there is no difference between these 2 ER diagrams. So that's why we call this as a conceptual ER diagram. So conceptually we may think it differently, but in terms of implementation of a relational database, they are same design like this. So ternary one-to-one relationship, it's the same. So when there is no maximum cardinality in the relationship, then we call that as a one-to-one relationship. And when you have a ternary one-to-one relationship like this, it will be exactly same. So in this case, we are talking about database system, about person has a passport and driver license, and it will be one-to-one relationship like this. Then the rule is that basically we are using primary keys of any 2 one-sided table as a foreign key in the other one-sided table. So in this case, actually there are multiple options. In this case, I put primary key of driver license and passport into person table, but you can also put primary key of a person, which is Hong Kong ID, into passport or driver license. That design also works because it's a one-to-one relationship. In one-to-one relationship, you can put primary key of any table into other table to make the foreign key. So again, this design will be same as this. So ternary one-to-one relationship will be exactly same as having multiple one-to-one binary relationship. So basically that's all about how to translate ternary relationship into relational model. As long as you follow these rules, it should be straightforward.